Hello everyone, my name is Aarohi and welcome back to my channel. So guys, in our last class, we have covered what Python modules are and how to create custom modules. And today we will learn about NumPy, which is one of the most important module in AI and data science. So what is NumPy? NumPy stands for Numerical Python, and it is a powerful Python library used to work with numbers in a fast and efficient way. Now, you might be thinking, why do we need a special library just to work with numbers? So, the answer is because computers understand everything in the form of numbers, whether it is text, images, or any kind of data. Before it is processed by an AI model, it is first converted into numbers. So, whatever input we give to an AI model, it is actually handled as a numerical data behind the scenes. And even when we train our AI model, a lot of mathematical calculation happens in the background. So in all these cases, we are working with numbers only. Now, another question is, can we use Python list for this? Because lists are also used to store multiple data points. And the answer is yes, we can use list for it, but lists are slow when we are working with large data. And in AI, we work with large data only, right? And lists are not efficient for heavy calculations. They are not designed for AI level operations. So that's why we use NumPy, because NumPy makes our work faster, easier, and more efficient. And guys, don't worry if this is not completely clear right now, because in the next few minutes, I will show you practically how NumPy is better than list, and then what are the different things we can perform using NumPy. So let's start with the practical implementation. And for that, we are going to use VS Code only. So let me open VS Code and first show you how to download and install NumPy and then how to use it. So write VS Code and open this VS Code editor. First, let me open a folder where we are going to work today. And I have created a separate folder with the name of NumPy tutorial. So let me open that folder. So go to File, open folder, then you will go to the drive where your folder is. So my folder is in D drive. So here I have a folder with the name of NumPy tutorial. This select this, then select folder. Right now this folder is blank because we have not performed any task yet. Now let's install the NumPy module. How to install NumPy module? First, click on these three dots and go to terminal and new terminal. So you have a terminal over here. First, you will write pip install NumPy. So enter. See, collecting NumPy. NumPy is getting downloaded and then installing NumPy package. So now NumPy is installed. The next task is to use it. So for that, in the front of this NumPy tutorial, you will see this first icon, new file. Click on it and name it first demo.py. .py. Why we are writing .py? Because this is a Python file, and enter. So whenever you want to use the NumPy module, you first need to import it. Import NumPy as NP. What does this mean as NP? It simply means that we don't want to write NumPy every time. We are using the short name for it. Wherever we want to write NumPy, we can simply write NP. Now let's see how to use NumPy. So NumPy dot array. So this is the function in NumPy using which you can create array. So NumPy dot array. Now in square brackets, I'm writing this 1, 2, 3, 4. Guys, what is this 1, 2, 3, 4? So if you remember, in Python, this is how we create list, right? So this is how we create list. And when we are working with array, we are just writing numpy dot array and then parentheses. And inside those parentheses, we are writing the list. What it means? It simply means we want to convert this list into array using numpy.array function, and let's store it in a variable ARR. So my variable name is this. Inside this variable, I have this numpy array. And guys, why we are creating this numpy array? Because whenever you want to perform any mathematical operation in numpy, you first store that data in the form of array and then you work on it. And in numpy, you cannot create array like this. Let's suppose you are writing this. Let me just copy over here, numpy.array parenthesis, and then you are writing 1, 2, 3, 4. So this is wrong. You cannot create array like this. Whenever you want to create an array, the data which you are providing it should be in the square brackets, means it is a list and we want to convert it into an array, or in the form of tuple. Okay, let me just copy it and paste it for you over here. See, array tuple means this. You put these brackets. Okay, so numpy.array function never take data directly like this. It will take the data as a collection. Collection means where you have multiple values, like you can provide list to it and then numpy array can convert it into array. You can provide tuple to it and then numpy array can convert it into array. Okay, now if you want to print this array, you will just write print and then the variable name where your array is. Now let me show you how to run this code. So first let's clear the screen, and we are in NumPy tutorial folder only, and in NumPy tutorial folder we have this first demo.py file. We want to run it, so you will write python first demo.py and enter. So what is the error? So you will write np over here. Remember, I've told you that you are using numpy as np, so you just write np at the place of numpy, np.array, and now you run the code. See, the output is this. So what is there in this array? These values. So we got those values over here. And guys, if you want to see the output of this one and this one, so just remove the comment and name it arr1. This is a variable name, and let's print arr1, and after that we have this. Let's uncomment it and name it arr2, and you can print this also. Save it, run the file again, and let's run the file. See, we got this output, the first one, and then we got error. Why? Because see, what is the error? Array takes from 1 to 2 positional argument, but 4 were given. So this is the error because of this. So I've told you that this is a wrong way. You will not use it. Now let's comment it and let's see if this one is correct or not. So let's rerun our code. See, you got the output. See, when you are providing the input to NumPy as tuple, it is working on it. So what we have learned till now, we have learned how to create one-dimensional array. So this is a one-dimensional array. Now let me show you the comparison of NumPy array with list. We will see which one is fast. List is fast or NumPy array is fast. And then we will see which one is better for mathematical calculation, NumPy array or Python list. Okay, so let's do that comparison. So for that we will create a separate file. So click here, and here you can write Python list versus NumPy array.py. So first let's create one Python list. So name it a equals to, and let's suppose we have these 4 numbers in it, right? And let's create one array, and I've told you how to create array. NumPy dot array parenthesis, and inside that you will create one list. So right now if you'll print the output will be same. The output of this and the output of this will be same. What will be the output? This much, the list, right? Now what is the difference? Let's see that. Now let's suppose you want to perform a mathematical calculation on list. First I'll show you how to perform a mathematical calculation on 2 lists, and then we will perform the same calculation on 2 arrays, and you will know the difference. So let's say we have another list with the name of B, and in this list we have 5, 6, 7, 8. So we have one list A, another list B. Now let's say we want to perform mathematical operation on it, and let's say we have another variable with the name of C and perform A plus B. Now print C. What do you think? What will be the output? We want to perform mathematical operation. That means the first element of A list should be added with the first element of B list. Second element of A and second element of B list should be added, and in the same way third elements and the fourth element. This is what we want to do. But let's print the output and see what we are getting when we are adding like this. So write Python and the file name is Python list. Okay, again this, it should be np, and we should import the NumPy before using it. Import NumPy as np. But right now we don't need this code, so you can comment this part. So because right now we are just checking how to perform mathematical operation on list. So save this file. Let's clear the screen and rerun this code. See what is the output? 1, 2, 3, 4, 5, 6, 7, 8. So this is the output. What happened over here? See, it concatenated both the list. Means first we have these 4 elements. After that we have these 4 elements. So concatenation is happening over here. This plus operator is getting used as a concatenation operator. Now let's see how to perform the calculation on 2 arrays. So let's just cut it from here and paste here. Let me uncomment it. So we have one array. Now let's create another array. A R underscore B np dot array parenthesis and then square brackets, and we have 5, 6, 7 and 8. Now let's just C equals to, now let's add these 2 arrays, this plus this, and let's print this. Okay, now we are printing array. Let's see. This is the output. The first element of first array and the first element of second array is getting added, and we are getting 6. Second element of both the arrays are getting added. Third elements are getting added, and fourth are getting added. See, actual mathematical operation is happening here. But with list, when we use the same way to add to list, at that time those 2 lists were concatenated. Now let me show you how to actually add 2 different lists in Python. So to perform the mathematical operation on 2 lists, you will use a for loop, and we will use one more list, a blank list in the beginning, and in that list we will store the results of addition. So let's say we have a list with the name of result. In this list we are going to store the element wise addition on A and B list, and then we will use a for loop for and take one temporary variable in range length of A. So what I have done here, see how many elements are there in both the list? 4 elements. So that means we want to run the loop for 4 times, and length of A will give you what? 4, because there are 4 elements. Range 4 means we want to run the loop for 4 times. And now we want to perform the element wise addition on A and B list. So you can write A I plus B I. So what it means? It simply means that first time when this loop will work, from A list it will pick the first element, and from B list it will pick the first element, and it will perform the addition. and you can store the result in result list. This result list, you can write result dot append, and then second element of both the list will be added, and then the third, and then the fourth. Now after that you can print the result, and this is how you perform mathematical operation. Let me show you the output. So let's just write print list, and here let me just write print array addition. Save it and run it. Now we can see the output of addition in list also and in array also. The output is same. See, the only difference is that when you are using array, at that time the operation is so simple. You just need to write this plus operator between the two arrays and you can get the output. But in list you need to use the loop and you are performing the calculation manually like this. So the number of lines, the number of code is more in list, and the process is simple in NumPy array. So from here only you can see the calculations are simple in NumPy as compared to list. So that's why lists are not good when you are working, when you are dealing with more data. So let me show you one more example. We will compare the speed of list with NumPy array when we are working with large data. So let's create a separate file for it and name it speed comparison.py. Here we will create two lists and two arrays, and we will store large data inside it, and we will see how much time NumPy array take to process it and how much time list take. Okay, so first we will import the time module. So we are importing time module. Why? Because we want to compare the speed, and for that we need time module. We want to see how much time list and array takes to process the same data. So that's why we are importing this module. And guys, this time module is a built-in module. Built-in module simply means when you install Python, this module comes with Python only. You don't need to install it separately like NumPy. We installed it ourselves, right? Because it is not a built-in module. But time is a built-in module. That means you don't need to install it yourself. So we are just importing it, and then import NumPy also as NP. Now, let's say we have a variable with the name of size, and in that I am writing 10 million numbers. So in size variable, we have 10 million numbers, and now we want to create two lists with 10 million number, and we will create two arrays with 10 million numbers, and then we will perform some mathematical operations on it, and we will see how much time lists take and how much time array is taking. So let's create first list. So write list and then use range and then provide size. See guys, we can create list like this also. We are not manually providing the values like this. So usually we have square brackets, and inside the square brackets we write the numbers ourselves. But right now we want to create a very big list with the 10 million numbers, so it is not possible to write all those numbers yourself. So you can use this range functions, and range function will give you the numbers till this. It will start from 0 and it will give you 10 million numbers. So in our list A we have 10 million numbers. In list B also we have 10 million numbers. Now let's create one variable start. This variable will store the current time, means before actually performing the mathematical operation on these two lists, we are storing the current time in the start variable. So start, we will write time, the time module which we imported above, time dot time. This code will give you the current time. The start variable, we are actually recording the time before running the actual mathematical operation on the list. So now here we will write the code for mathematical operation, and I've told you we will use for loop. So guys, what you can do is you can directly copy the loop code from here, list loop code, which I've shown you earlier. So see, we have this result blank list. Here we will store the output, and our list name is list A, and here write list A, and here write list B. See, this is how we perform mathematical operation. Now what will happen? This loop will work for how many times? 10 million times. Why? Because there are 10 million records and we want to perform element wise addition. Now this loop will work for how many times? 10 million times, and then you will see the output. And after that, let's have one variable with the name of end, and in this end variable we are recording the current time again. See, before running this code we are recording the time, and after running this mathematical operation we are recording the time again. Then we can subtract the start from end time and we will know how much time it took. Now you can simply write print end minus start, and let me write here list addition. So here you will get the time, how much time list took. Now let's write the same code for array. So these are the two arrays, array A, numpy.array, list A. Remember, whenever you want to create an array, you provide list to it, then numpy.array function convert it into array. So the list, this same list, these two lists, I'm converting them into arrays. Now let's use the start variable again to record the time. Start time dot time parenthesis, and now you will write the code which will perform the calculation, and you will write result A, this array plus with this array. So this is the calculation. Now you will write end variable. Again you will record the time after the calculation, and then print, and in double quotes write array calculation, and here write end minus start. Save it and let's run this code. So Python, what is the file name? Speed comparison. See, list took 1.15 seconds to process this, and array took 0.06 seconds. So from here we can straight away see that NumPy is faster as compared to list. NumPy is simpler to use, so that's why we use NumPy over list. Now you know what is NumPy, why we are using it, how NumPy arrays are better than Python list. Now let's see what are the different properties of arrays. So for that, create one separate file and name it array properties.py. And here first import NumPy as np and create one array, and you create array like this, write numbers inside it. Guys, this is a one-dimensional array. Okay, in some time I will show you how to create 2D and 3D arrays also. So now if you write arr.shape and print it, print arr.shape, save it and run it, Python, and the file name is array properties.py. See, what is the output? 4 and then comma. Right? What it means? It means we have 1D vector 1D array, and in that we have 4 elements. Now let's create 2D array. So arr2 equals to np.array parenthesis. Inside it, we are going to create 2D array. 2D array simply means rows and columns. So one list means one row, second list means second row, and then third list means third row, and fourth list means fourth row. So 4 list means 4 rows. Now let's write some data in it. 10, 20, 30. In first row, we have these 3 records: 40, 50, 60, 70, 80, and 90. And then let's say 75, 85, and 95. So now we have 4 rows. Okay, 4 rows. And how many columns? 3 columns. 10, 40, 70, and 75 are in first column. So this is a 2D array. 2D array simply means when you have rows and columns, and rows simply means how many different lists you have. So if you want to check the shape of it, now let's check the shape of this and then print it. See, now we are printing the shape of first array, this one, and now after that we are printing the shape of this. So let's print it. Okay, so what is the error? Oh, so basically you will create list, start list here, and that list will end here. Everything I have told you earlier also, that everything will be given to a array as a single collection. Okay, single list or a single tuple. So we started one list in the beginning of all these lists, and we are closing it over here. Save it and run the code again. First clear the screen and let's run it. See, now the output is this: 4 and 3. What does this mean? 4 3 simply means we have 4 rows and how many columns? 3 columns. And shape tells you how many rows and columns you have in your array. Now the next thing is to check the dimension, means whether it is a 1D array, 2D array, 3D array. Okay, so for that you will write arr2 dot ndim, and let's just print it. And in the same way you can print the dimension of this array also. So let's print it over here only. So now we are printing the dimension of both the arrays. This ndim will simply tell you the dimension, whether it is 1D or 2D or 3D array. Okay, so let's just run it. See, this one is 1D array and this one is 2D array. So that's why we got 1 and 2 over here. Then there is another thing, AAR dot size. Size simply tells you how many elements are there. So let's print the size of first array and let's print the size of second array. So in second array, how many different elements we have? 3, 6, 9, and 12. And in first array, we have 4 elements. Okay. So let's just print it. See, 4 and 12, because size simply tells you how many elements are there. So we know that there are 12 elements in ARR2 and in ARR we have 4 elements. Now let's say you want to know the data type of the array. So you will write ARR dot D type. So this will tell you the data type. Print, save it, and if you want to check the data type of the second array, so that too you can write it like this. See, the data type of first array is int64 and the data type of second array is also int64. Let me just comment all this and let me teach you the next concept, which is indexing and slicing. Now we are going to learn indexing and slicing. Let me show you the indexing and slicing concept with this array only. So let me just copy it here. And now suppose you want to print only the second element of first row, right? So for that, what you will do, you will write the array name. Array name is this, array2, square bracket. First, you will mention the row number. So we want to work on the very first row and the index start with 0. So the row which is at the first position have index 0. This row have index 1, this have index 2, and this have index 3. In the same way, column index also starts with 0. So this is a index 0, this is index 1, and this is at index 2. So right now we want to access this element. So that means row 0, row which have index 0, and the column which have index 1. So write 0, row, column 1. And let's just print. Output should be this, okay, 20. So let's just print it. Save it and run it. See, the output is 20. Now let's say you want to see the last column of the first 3 rows. So what will you do? You will simply write ARR2 square brackets. So we want to access the first 3 rows. And I've told you that the index starts with 0. That means first row have index 0. So you will write here 0 colon 3. What it means? It means you will get the records of 0, 1 and 2. So this is for row. We are simply saying row starting from index 0 and row which ends before 3. So row ends before 3 is 2 only. So now you will mention the column number. Which column we want to see? The last one. So the last one is 2. So you can write 2 over here and then print it. Print and see the result. See, the output is 30, 60 and 90. This is what we want to see. Okay. And copy this part from here and paste it here. Instead of writing 2, you can write -1 also. -1 simply means the last column or the last row. If you will write -1 over here, that means last row. And after comma, if you're writing -1, that means the last column. So you can run, you will get the same output here also. See, 30, 60 and 90. So this -1 is to access last item. Row, it can be row or a column. Now let's say you want to access all the columns of last 3 rows. For that, what will you do? You will write array name, square brackets, and we want to work with last 3 rows, right? So that means we don't want to work with index 0. The index should start from 1 index, 1 colon. You will write 1 colon 3 comma colon. This colon means all the columns. And before comma, this means row should start with index 1 and it should end before 3. Now print it. What will be the output of this? The output will be that we want to access all the columns, but we don't want to include this row. Okay. So clear the screen. Let's just print it. See. Why we are seeing these two output only? Because I have mentioned you that if you will write 3 over here, it will take 1 record before this. So you should write 4 over here in order to see all the records. See now. Now we have the last 3 rows and all the columns. So guys, this is what indexing and slicing is in NumPy. Now let's see some mathematical operations. So we will work with this array only. Just copy this array over here. Now let's suppose you want to perform addition on this array. So what you will do, you will write np dot sum parenthesis. You will write the array name, comma, and then you will tell that whether you want to perform addition column wise or row wise. So if you write x is 0, x is 0 means column wise. Okay. And let's just copy this and write it over here. And if you write x is 1, x is 1 means row wise sum. X is 0 means column wise sum. And x is 1 means row wise sum. So we can print both the outputs. Print this one. And then print this. Save and let's see the output. Clear the screen. Let's run the code. See, you got the output. See, column wise output. How do you know that this is a column wise output? Because how many columns we have? We have 3 columns. So it added all the elements column wise and gave us this output. And then in next list, we have 4 values. Why? Because there are 4 rows and we have performed calculation row wise, because axis 1 means row. Okay. So this is again very important. X is 0 and X is 1. Guys, why I'm telling you all these functions? Because these functions we will use when we will work with AI, machine learning and deep learning algorithms. So guys, like this, there are other mathematical operations like this: np.mean, max, and minimum value. It will give you a minimum value. It will give you a maximum value from this array. This np.mean will give you a mean. Okay, you can try this yourself. I'm commenting them. Now guys, the next thing to understand is reshape. Let's just copy this from here. Let me create a separate file for this and name it array reshape example.py. And let me just paste this array only, and let's import NumPy as np. And if you want to check the shape, I have told you that you can write this print array.shape. Okay, let me print the shape first, and then I'll show you why we use reshape. Because reshape is very, very important in data science and AI. Because every AI model, they they take input in different format. So we need to arrange the input in the way that particular model accepts. So we use this reshape almost in every program. So I will explain you in detail why we use reshape and what are the different ways to reshape your data. So first, let's see the shape of this. We know this is a 2D array. Why? Because there are rows and columns. And let's print it. Python array reshape. Okay, so we have 4 rows and 3 columns. Let me just paste it here. We have 4 rows and 3 columns. Now let me show you how to use this reshape. So you will write array name and then you will write reshape parenthesis, and here you will mention rows and columns. So let's say I've mentioned 2 rows and 6 columns. Why 2 rows and 6 columns? We have 12 elements. So guys, always remember while reshaping that you are not changing the data. The data will be same. The number of elements will be same. You are only arranging them. You are only changing the shape. Okay, how they are arranged. So 2 6 simply means I want to have 2 rows and in each row there will be 6 items. So the total will be 12 only, right? So the number of elements will remain same. The way you arrange them is different. Let me just print it and show you. Print. Oh, sorry. Let's just print this. See what happened. See here. Now the data is same 10, 20, 30, 40, 50, 60. These two rows are arranged in one row and the next two rows are arranged in next row. But the elements which are there are same. The numbers are not changing. Now let's say, let me just comment it and let me just write here 3 rows and 4 columns. Now again, instead of 4 rows, what I want 3 rows, but in each row I want 4 columns. Now what will happen? The data which we have in this array 2 will be arranged in this way. So let's print it and see. See, we have 3 rows and in each row we have 4 values. So first row have 10, 20, 30 and 40. See, right? And second row have 50, 60, 70, 80. And the third row have this. So this is what array dot reshape does. And whenever you use array dot reshape, you only need to take care of one thing, that the number of elements should be same. The way you want to arrange them, that is your choice, how you want to arrange them. It is not actually your choice. It depends upon the model which you are using, because every model accepts data in a different way. So you need to arrange your data according to that. So for that, we use reshape. And guys, sometime you need to arrange your data in 1D vector also, 1D array also. So you will write arr2 dot reshape. You will simply write 12 and then comma. What will happen with this? You will have all these records elements in one single row. See, you have the output in one single row. And guys, this part is known as flattening the array. And this we use in object detection, and we use it in image related algorithms. They all use this part, flattening the array. Okay. One more important thing. See, when I've explained you about this Python versus NumPy array, over there, one more thing I will explain you, that NumPy is fast because of vectorization. And what is vectorization? Vectorization simply means that all the operations are getting performed at once. Means if there are 4 numbers, 4 elements in first array and 4 elements in second array, so the mathematical operation is getting performed at once only. It is not like that after the first element of first array and the second first element of second array will be added, and then the second element of both the arrays will be added, and then the third elements. No, it is not happening like it. Everything is getting handled at once. But in list, the operation is getting performed in a loop, and in one time one value is getting added or multiplied, or any mathematical operation which you want to perform. So this concept in NumPy error is called vectorization, and because of this vectorization only, NumPy task is fast. NumPy perform your work in a more efficient way. Okay, so now the link of the code is given in description section. You can get this code from there, and I hope this video is helpful. Thank you for watching.